One quiet winter morning, parents across Europe were told to pull chocolate off their shelves immediately. The product looked perfect. The factory records showed nothing wrong, but somewhere inside a modern food plant, something microscopic had slipped through, and within days, hospitals were reporting sick children. That moment is the hidden shadow behind today's chocolate industry. And it is why the factory that now produces one of the world's most famous spreads operates with a level of control that feels closer to a medical lab than a sweet shop. Behind the glass walls, the stainless steel machines, and the hypnotic rivers of chocolate, this is not just about taste. This is about risk, pressure, billions of dollars, and a past failure the industry never wants to repeat. If you've ever watched liquid chocolate pour like silk and wondered how something so simple feeds half the planet, you're in the right place. And if stories like this matter to you, quietly join this channel now. Not for algorithms, for the truth hidden inside everyday products. This factory does not just make a spread, it makes consistency. It makes trust. Every year, hundreds of thousands of tons of this chocolate hazelnut blend are consumed across more than 160 countries. It goes into school lunches, breakfast tables, cafes, bakeries, military rations, hotel buffets, and emergency food stockpiles. When this production stops, supermarkets feel it within days. When it fails, governments pay attention. This is modern mass food manufacturing at its most precise. And that precision was not built by comfort. It was built by catastrophe. The process begins long before the first drop of chocolate appears. It starts with hazelnuts delivered by the truckload from Turkey, Italy, and South America. Each shipment is tested before it ever enters production. Moisture levels, mold, aflatoxins. One contaminated batch can trigger a recall across continents. Hazelnuts are a living ingredient. They rot silently, and when they fail, they carry invisible poison. They are roasted next. Giant rotating drums raise their temperature with brutal accuracy. Too cold, and flavor dies. Too hot, and bitter compounds form. Inside this heat, pressure builds. Oils separate, shell fragments shatter. This stage alone has caused factory fires in the past, when dust ignited in oxygen-rich air. One spark here can become an explosion. From roasting, the nuts drop into crushing mills. Steel teeth reduce them into thick paste. Friction here is constant. Bearings burn out. Shafts misalign. A single broken metal shard can enter the food stream if detection systems fail. That single shard is enough to shut down a billion-dollar line. At the same time, cocoa arrives, fermented, dried, shipped across oceans, ground into powder. Cocoa carries bacteria when stored poorly. It absorbs moisture from air. It attracts pests. It is both essential and dangerous. When cocoa goes wrong, it does not announce itself with smoke or fire. It waits. Sugar enters next. It flows like dry sand through hoppers taller than houses. Static electricity can cause it to ignite. Sugar dust explosions have flattened entire food plants in the past. This factory runs humidity controls around the clock to prevent that dust from ever reaching ignition levels. Then milk powder is added. This is the most sensitive of all. It supports life, which means it also supports bacteria. One unnoticed moisture leak in a silo, one unclean pipe bend, one overnight temperature drift. That is enough for contamination to begin. Inside sealed mixing chambers, all of these ingredients meet. Hazelnut paste, cocoa, sugar, milk, emulsifiers, heat, pressure, time. The machines here do not simply stir. They shear, fold, compress, and liquefy under computer-controlled force. Every second is measured. Viscosity, particle size, temperature to the 10th of a degree. This is where tiny mistakes grow teeth. If the mix is too viscous, pressure increases downstream. Bearings strain. Pipes vibrate. Seals weaken. Product can leak into machine housings and go unnoticed. When that residue builds up, it becomes breeding ground. Warm, sweet, hidden. The next stage is refining. Massive steel rollers grind the mixture until its particles are small enough for the human tongue to perceive it as smooth. These rollers run under crushing pressure, 24 hours a day. If one roller drifts out of alignment by less than a millimeter, heat spikes. Heat destroys texture. It also weakens metal. And metal that weakens can fail without warning. From refining, the mixture flows into conching. This is where the final texture and aroma are formed. Huge temperature-controlled vats knead the chocolate for hours or days. Air is introduced in controlled amounts to remove volatile acids. Too much air invites moisture. Too little traps acidity. Both ruin millions of units in a single batch. The last stage before packaging is tempering. The chocolate is cooled and reheated in a precise curve to stabilize its crystals. This determines whether it spreads like silk or crumbles like chalk. If tempering fails, entire production runs are scrapped. None of these machines are safe tools. Each is a loaded system under constant stress. And in 2019, in a different factory owned by the same parent company, one of these systems quietly failed. In Belgium, a production line making chocolate treats detected salmonella. The bacteria had entered through raw materials and survived inside a hidden section of processing equipment that routine cleaning never reached. For months, nothing happened. The machines ran, the products shipped, the shelves filled. Then the reports began. Children in multiple countries fell ill. Governments issued warnings. Stores pulled products by the millions. Entire production lines were stopped overnight. The financial loss reached hundreds of millions. The damage to trust was worse. No explosion, no smoke, just silence, followed by panic. Investigators traced the outbreak back to a single processing unit where moisture had condensed inside a sealed pipe after maintenance. The pipe was never fully sanitized. A microscopic colony survived. And from there, it spread batch by batch, invisible to the eye. This was the moment the industry changed its definition of clean. After that incident, chocolate factories around the world tore open machines that had not been fully disassembled in decades. Design rules were rewritten. If a human hand could not reach it, water would. If water could pool, the machine would be redesigned. Pipes were shortened. Angles were changed. Sensors were added, not just for temperature and pressure, but for bacterial signatures in real time. Today, inside modern production, every stage is wrapped in redundancy. Ingredients are tested when they arrive, while they rest in storage, before they enter blending, and after they exit packaging. Air itself is filtered. Workers pass through hygiene zones, boot washers, UV hand scanners, full clothing changes. The factory floor is quieter than you'd expect. Machines dominate the soundscape, not people. Most control happens from sealed rooms lined with screens. If pressure rises by a fraction, if motors draw slightly more current than normal, if humidity drifts, the system reacts automatically. Lines slow, valves close, alarms trigger. A mistake still begins small, but now it is hunted immediately. Packaging is the final gamble. The spread flows into jars at blistering speed, thousands per minute. If even one jar leaves with defective sealing, oxygen can enter. Oxygen invites mold. Mold invites toxins. Detection cameras scan every lid, every thread, every vacuum seal. Even labels are checked by machine. A wrong ingredient list is now treated as a legal hazard, not a clerical error. Each finished pallet is tracked digitally. If something fails later, the factory can trace it back to the exact minute and machine that produced it. Modern chocolate is not just food. It is data. The old disaster forced this evolution. Machines that could not be fully cleaned were scrapped. Older conching systems were replaced with CIP designs that flood every internal surface with sanitizing fluid. Heat exchangers gained automatic sterilization cycles between batches. Even floor drains were redesigned because investigators found bacteria living inside them, creeping upward during shutdown nights. Every change was expensive. Every upgrade slowed production. And yet the brand survived because it adapted before public trust collapsed entirely. Today, when the product flows into its final container, it does so under stricter conditions than many pharmaceuticals. Its texture is measured. Its microbial load is tested. Its shelf life is simulated in climate chambers that replicate desert heat, Arctic cold, and monsoon humidity in fast forward. And still, the factory never fully relaxes because the lesson of that silent outbreak still echoes through every stainless steel pipe. A system can look perfect and still be dangerous. Documents can be accurate and still lie. A factory can pass inspections and still hide a flaw no one thinks to search for. That quiet lesson is now embedded into every modern food facility on Earth. And this is where the story turns back to the jar on your table. The final product you spread on toast is now the result of controlled pressure, controlled heat, controlled exposure, controlled bacteria, controlled time. Every spoonful is mapped to machines that no longer trust themselves. Every batch is assumed guilty until proven clean. You don't taste that history. You don't see it. But it is there in the silence between machine cycles, in the sensors blinking green on control panels, in the redesigned pipes that no longer trap moisture, in the obsessive cleaning schedules that never end. This spread is smooth today, not just because of refinement, but because of fear. Because once something slipped through, and the industry decided it would never let that happen again. The next time you twist open a jar, you're not just opening chocolate and hazelnuts. You're opening a product shaped by machines that failed, by illnesses that spread quietly, by trust that almost broke, and by a system rebuilt under pressure. If stories like this linger with you, stay with this channel, because every massive industry we touch has a moment it would rather forget. And those moments are the ones that built the world you live in. So here's the question that stays behind after the lid is closed. Would you still trust this product in the same way if you could see everything that almost destroyed it?